APIs are everywhere and we use them daily. From booking tickets to making payments and logging onto our favorite social media website, APIs are omnipresent. The world of APIs is vast and certainly worth exploring. As a result, understanding APIs has become a crucial part of tech interviews. In this video, we are exploring 5 API development approaches. Hi there, welcome to Tech and Career Bytes. I'm a software professional with over 2 decades of experience, including 7 years in leadership roles at a global product based organization. If you are working in the tech industry or are a tech buff, you must have encountered the term API. Today, APIs play a significant role in the economy than ever before. As we mentioned in the beginning, APIs are everywhere and we use them daily. So, without further ado, let's begin our discussion on 5 widely used API development approaches. An application programming interface or API allows two software components to communicate, share data, and perform useful tasks. These software components can reside on same machine or different machines connected through a network. Using an API, a software component can request services from another software component without needing to understand its underlying architecture. Imagine you are using a weather app on your phone to check the current weather. The weather app does not generate weather data itself, but uses an API to retrieve it from a weather service. Here, the weather app acts as client. The app requests the current weather for a specific location, and the weather service acts as a server. The weather service processes the request and sends back the weather data. There are many ways to develop APIs. In this video, let's explore 5 common API development approaches. Representational state transfer or REST is an architecture style that uses HTTP requests to access and manipulate data. It treats server data as resources that can be created, read, updated, and deleted using standard HTTP methods get, post, put, and delete. You can learn more about HTTP methods, HTTP based data fetch patterns, and HTTP based event driven protocols in our videos linked in the description box. REST is stateless. Each request from client to server must contain all the necessary information to understand and complete the request. The server does not store any client context between requests. REST emphasizes on resources and their state. Resources are identified by URLs. Resource state is transferred over HTTP in a textual representation like JSON or XML. To know more about stateful and stateless architecture, you can watch our video. The link can be found in the description box. Consider this example. A RESTful web service for a blog might provide a URL like example.com/articles for accessing articles. A GET request to that URL would retrieve articles, and a POST request would create a new article. REST stateless interactions improve scalability. Each stateless request is complete and self-contained. This simplifies monitoring and debugging. Leveraging HTTP caching in REST improves performance by reducing latency, server load, and network traffic. This leads to efficient and responsive application. Overfetching or underfetching of the data than needed are common challenges in REST API that impact performance and efficiency. Now, Let's discuss our second API development approach, GraphQL. GraphQL is a query language for APIs and a runtime for executing those queries. It was developed by Facebook in 2012 and released as an open source project in 2015. Unlike REST, which uses multiple endpoints, GraphQL uses a single endpoint to fetch the required data. Using GraphQL, clients can specify exactly what data they need, making the queries precise and efficient. This also eliminates under and overfetching of the data. GraphQL enables efficient data fetching by allowing multiple related data requests to be combined into a single query, eliminating the need for multiple round trips to the server. It supports aggregating data from different sources within a unified query, such as retrieving a user's profile information from one service and their recent activities from another service simultaneously. The flexibility of GraphQL can cause performance issues if queries are excessive. To prevent this, developers should use safeguards like query depth limits, query complexity analysis, and strong authentication. GraphQL's query flexibility makes caching harder because we need to carefully decide when cached data is still valid or needs refreshing based on query parameters. Technologies like SOAP, JSON based RPC, and REST have limitations such as tight coupling, additional processing, header overhead, interoperability issues, and so on. This led Google to develop gRPC, our third API development approach. gRPC is a high performance RPC framework that leverages HTTP2 multiplexing and protocol buffers. HTTP2 multiplexing is beneficial in creating logical subchannels to support following types of connections. First, request response. The client can send a single request and the server can reply with a single response. Second, client streaming. The client can send multiple requests and the server can reply with a single response. Third, server streaming. The client can send a single request and the server can reply with multiple responses. And last, bidirectional streaming. The client can send multiple requests and the server can reply with multiple responses. gRPC internally manages these HTTP streams to create subchannels and abstract the details from the client at the application level. gRPC uses protocol buffers, a binary representation of data for storage and transmission over the network. You can learn more about protocol buffers and how LinkedIn benefited adopting protocol buffers in our video. The link can be found in the description box. Let's proceed to our next API development approach, MQTT. MQTT is a lightweight publish subscribe network protocol well suited for API development, especially IoT applications where devices communicate with a central server or broker. Publishers send messages, subscribers receive them, and brokers manage message distribution. MQTT is optimal for IoT devices with constraints on processing power and network bandwidth. Imagine a home automation system where various sensors like temperature, humidity, and devices like lights, thermostats communicate with each other. We are developing an API for a smart home system where various devices need to communicate in real time. MQTT can be used to facilitate this communication efficiently. Serverless architecture is a cloud computing execution model. Here, the cloud provider dynamically manages the allocation and provisioning of servers. With serverless, developers can focus on writing code without worrying about the underlying infrastructure. This is particularly helpful in API development, where the backend logic can be implemented using functions triggered by HTTP requests. For example, consider a simple to-do list API using AWS Lambda and API Gateway. AWS Lambda is a serverless compute service, and API Gateway is a service for creating and publishing APIs. You can learn more about API Gateway in our video. The link is available in the description box. In today's technology-driven world, APIs play a crucial role in enabling smooth communication and integration between different software systems. Whether using REST, GraphQL, gRPC, MQTT, or serverless, it is essential for developers to know these options. Selecting the right API approach enhances software capabilities, boosts performance, and helps meet the evolving needs of digital environments. If you found this video helpful, give us a thumbs up and subscribe to our channel for more interesting tech topics. Do check out our other videos on software performance optimization case studies, coding, system design, big data, and career growth. My name is Rupa, and I thank you so much for watching this video. See you next time.